Hey guys, Kodak Carlos here. Welcome back to the workbench. So if you've been following along so far with the various builds and coding I've done, I'm building a set of controllers and sensors for my laser cutter. So today I thought I'd take you quickly through the actual controller side of it. So as you can see, here's a picture of it running, deployed onto a little Raspberry Pi. So this is I think it's an 8.7-inch touch display. Bought from Amazon. They're not too bad actually. It's 820 by 340 or something. It's a really weird resolution anyway. So as you can see, this is the back of it. So key thing to note is the display actually plugs into the display adapter on the Raspberry Pi. So it's not actually an HDMI screen or anything. It is actually literally just hardwired into the Raspberry Pi. We can see the power supply coming out here. And then you've got the three USB connectors here, and they run off to the three sensor boards that we've built in the last set of tutorials. So yeah, so what's this one? This is a 3 Model B Plus, so it's not particularly powerful. It's one I had lying around that fitted nicely. Yeah, and as you can see from the result, it works quite nicely. I haven't turned the pumps on for this picture because if I do that, it's a bit noisy because it's sitting literally right beside the desk. But when it's running, I'm getting currently about 1.5, I think it is, 1.5 litres per minute on the coolant flow, 1.6 to 1.8 on the ice flow, and then the bottom here, which I've got set up, is what I'm doing is I'm measuring the temperature beside the laser tube, what humidity is right beside the laser tube, and this calculates me the dew point temperature. So if the coolant temperature, somewhere between these two gets near close to this, it means that there is a potential of condensation forming on the outside of the tube, which you really don't want. So yeah, it's just there at the moment. And down this bottom I have controls I can touch to turn on the lights, turn on the fans, enable the ice bypass, which to be fair, on the current setup, I don't have running. I ran into a few problems with that, in that the solenoid I was using, even when it was fully energized, the water wasn't actually being bypassed. It was still flowing through the main loop. So I need to get a different solenoid. So I've disabled that at the moment. It's just ignored. The solenoid will go click, but nothing will happen. And then as long as the coolant temperature is appropriate and the flow is right and this top line of there is all green, this will turn green and the laser will be enabled, and you'll actually be able to actually start burning stuff. So yeah, so onto the code. So this is the code. It's freely available up on GitHub. I'll put the link in the description below. If you go to the README, it's fairly simple. I'll move this over. Fairly simple to set up. We have examples for whether you're under Linux or Windows. And then I've set up to use virtual environment, which just seems fairly good for Python. So set it up, activate the virtual environment, install the requirements, and then run it. That's it. It's not hard to do. The packages I'm using aren't particularly ground shattering, earth shaking, what do you want to do? Bit of YAML parsing, the library for connecting to serial, pillow for image analysis, image processing. So that's the thing which does the digits. So these digits here that you see on the screen are actually just GIFs that I'm using Pillow to scale up to the right size and link together to actually give me a single image there. So, and then config parser passes a config file here, and then you just tell it where I can find the 3 controllers. Now, if you remember the tutorials where I set up the various controllers, the ice controller returns ice, the laser controller returns laser and such like. These don't need to be in any particular order, because when I boot up, so if we just a quick look, main, set the ranges, so this is how I'm controlling the colors. Sure, there's a better way of doing this. I just haven't got a chance to do it. It's basically building up. This is all just set up, basically. Sorry, I'll rephrase that. That's setting up the ranges. This is setting up all the various display fields. So I'm using, what's it called? PK Intra? No, where is it? Where is it? Which one am I using? Display. Using TK Intra, which is TCL TK, which is a display system used for Linux. I wrote C++ when I was doing my university degree many years ago. So what these are is these are float values that get interrogated by the display unit and is shared between here and the sensors. So the sensors update it, display changes it, etc. So those are the fields. So as you can see, the 3 fields for the coolant, 3 fields for the ice, 3 fields for the temperature, and then the 4 controls at the bottom. Groups of controller, passing in the various bits and pieces that it needs. The screen. So the controller is what determines whether stuff gets turned on or off. The screen is used to display everything, obviously, and sensors. Now, the sensors is an interesting one. I had fun with this one. Where are we at? Start sensors. So it starts off. No, that's sensors. Where is it? Down the bottom somewhere. Here it is. So when sensors starts up, it pulls in these 3 controllers and goes, right, well, we've got 3 ports, but we don't know what they are yet. So for the first one, we'll connect to it. So, we pull the information. We don't know what's connected to them. We say, look, if we talk to this one and it gives us the word laser, that's our laser one. Coolant, ice, ice. Otherwise, if we've talked to something else which comes back, beer fridge, it'll go, I don't know what to do with that, and bail out. So that'll connect. And if you watch the ones where I set up the serial comms tutorial, I've got to put the sleep in for some reason. So it takes, what's it, 3.8 times 3 is 5 seconds or so to actually boot up. So when you first start the controller, it sits there for 5 seconds and then the screen appears. Annoying, I could set it to run in a background thread, but can't be bothered. Once it's up and running, I'm quite happy with it. Fire the ID string out, wait for the response, which has to be one of these. And then, as you can see, it returns whatever you set up. So in the main, when you're then saying, this is the laser sensor, laser sensor set up, here's the field that I'm going to update when I get information from the sensor, and that's the port I'm using. So if we have a look at the laser sensor, here's the 3 fields I'm going to update. When I update, now this is running in a separate thread, so this is what I'm doing in separate threading. So this one updates every 7 seconds. Let's update every 7. And the other ones does it some other time. But yeah, so the laser sensor every 7 seconds, waits 7 seconds, then starts scanning. And I bet you I've set it up. It's been a while since I wrote this. The coolant sensor, it sleeps 7 seconds as well. That's the laser sensor. Come on, I said coolant. Yeah, there's coolant. It delays 5, ice delays 6. So after 5 seconds, the coolant sensor starts polling. Then a second later, the ice sensor starts polling. And then a second later, the laser sensor. And then they're each polling every 3 seconds. So I have a poll every second. So basically, when the display is actually running, you'll see it updates every second. Something on the screen will change. And then you're just doing the math. So, getting the humidity, getting the temperature, so the other way around, temperature, humidity. and then calculating the dew point, which is a standard what's the word, formula you can download from the web. So the actual sensor unit doesn't calculate the dew point. I calculate it here. And then what this does, it sends a laser update. So this is an event for the TK Intra GUI system. So this, if you have a look in the display, will come through here and say, was it on? Should be an on event somewhere. There, 800 by 480 is the screen, so it's a reasonable resolution. Where is it? Somewhere down here. Yeah. So it says, if I see the event calling update, call this method, ice update this method, this method, this method. And then all you're doing is you're seeing here, it's saying, well, look, set this element, update it, and I'm passing in green, orange, and red number images. And these are just the images here. So if you look at low green numbers, I could have done this in an array, been a bit nicer, but I think it's easier to copy and paste. It just loads all the green digits, funny enough, orange digits, and red digits, and loads them all up. And what it does here is it then scales them. So I've pulled them in at a standard image size. Standard images. Image size is that. There you go. 142 by 245. So 142 across, 245 high. I don't know why I chose that, but it just seems to work. Where's the display? Numbers. Up here. And then it scales them. So when I was designing this and playing with it and running it, I actually found that if you scale them by 45, 0.45 down to 45%, it fits perfectly on the screen. So if you ever copy this code and fire it up and get it to a different screen, and you buy yourself, a 12-inch screen or a 4-inch screen, you just change these numbers here. Initially, I was scaling the decimal points a bit differently because it looked better, but eventually it came back to the same size. And that's about it, really. There's not a lot of the code. So, sensors go around a loop once every 3 seconds. Each one of these gets updated, fires a message off the display. So, we toggle, where is it, the updates? Updates down the bottom, wasn't it? So it just then updates temperature, humidity, and dew point, and then updates system statuses. And this one here basically goes through and says, look, so that's a controller method, that's why. So what this does is it goes through and says, well, let's get the input temperature, let's get the flow rate. Is the coolant flow rate acceptable? So as long as it's flowing faster than the low warning, which, if you remember, is set up right up the top here. So it's as long as we're getting at least 1.2 liters per minute, that's fine. Is it too hot? So it says, are we above warm? Is the coolant temperature warm? Basically it says, is it too warm? And then are we too cold? So those two are used to control the laser. So as you can see here, as long as we're flowing enough and we're not too hot, enable the laser and then tell the screen we're enabled. Otherwise, turn them both off. If the temperature is too warm, we enable the bypass. The reason it's false rather than true is because of the way the solenoid worked. And then if it's too cold, turn the bypass on. That's right. If we're too warm, we want to turn the bypass off so it starts flowing water through the cooling system. If the temperature is too cold, we want to turn the bypass on, which is inverted logic. I know it's a bit confusing, but the bypass is turned on if we're too cold. As I said, this piece of code actually has no impact at the moment because of the way I've disabled the system. What else is there to say? Not a lot, really. Double constants for TK Intra. So the controller's just the brains. So my idea is at some stage I'm going to go through and make this a little bit cleverer, so it actually can start applying hysteresis. So if it sees the temperature of the output is rising, it might turn the coolant on earlier. But if it's slowly rising, because I'm not doing a huge, let's just say, for example, I'm doing a whole bunch of engraving, which is normally at low power, it doesn't need to turn the ice on as fast as if I'm doing a lot of heavy, deep cuts, which this laser then runs at 80% power, which is a lot hotter. Display, it's not pretty code, I'll admit, because I'm not an expert at this TCL TK. A lot of it's just a lot of copy and paste. So as you can see here, this column, this row, this column, this row. It's not pretty, but it seems to work all right. And yeah, I like having descriptive names, which unfortunately does mean occasionally stuff gets dropped off the side here. And yeah, it's MIT license, so basically grab it, do what you want with it, and please quote me on it, give me credit, but hey, it's do what you want with it. No warranties, no things. If you use it and something goes wrong, don't blame me. Let me know so I can fix any bugs you find. But yeah, so that's it, guys. And as I said, it does work. The numbers update quite happily. It's visible enough sitting there on the side of my machine. It's still got, as you can see, it's still got the foil on it. So the plastic on the outside. I'm gonna 3D cut a 3D cut? No. So I've been doing lots of 3D printing recently. Cut out a mounting unit for it and actually fix this into a nice box that sits there. Cables currently, I don't know if you can see in this image. Yeah, cables currently coming out of the bottom of the control unit. It just runs outside and then runs up and plugs in here. So I want to tidy up the cables. I want to drill a hole in the side and get the cable to come out and then in. I'm going to mount this. I was going to mount it up here, but I think I will actually mount it and have it in a little separate module here. You've got a switchboard there with all the different units you turned on. Yeah, that is probably one of the biggest changes I've made to the control panel so far. Rather than just having a push button like this, I've actually got a proper on-off key switch, so I can take this away if I'm not going to be in the shed for a while, which means no one can play with it. Yeah, I'm a non-professional apparently, but I've been laser trained years ago. So yeah, so that's what it is. That's how it works. My first plan, which is now I've got the system up and running and got the light system all tuned up, so it's now focused properly. I'm going to rip this control panel out and actually replace it with a laser engraved acrylic panel. Probably move some stuff around. Don't really need to worry about that sort of stuff, but yeah, just tidy this up. Actually, I just had a thought. I may be able to mount that in here. Cut that away and actually mount it into the box. That would make sense, wouldn't it? Something to think about, because that looks like it might fit. And I just need to wonder where I'm putting those. Put those down there, maybe. Something to think about. But yeah, so that's the laser monitor. That's the software. So feel free, like and subscribe. Leave any comments, leave any questions, etc. below. And yeah, have fun. I'll catch you later, guys. Bye.